So let's talk a little bit about waves. Waves. And a wave is basically some energy that is propagating throughout space. So we have energy that is going to some final destination. Now let's think about a traditional wave, also known as a longitudinal wave. And to represent this, I have a slinky. Here's my slinky, and two people on each side. And person A moves this side of the slinky up and then down, and then does it again. Now what he's doing here is an oscillation, up, then down, then up, then down again. What that does to the slinky is it creates a wave pattern, something like this. Now this is known as a sinusoidal wave pattern, and also can be called a transverse wave. So transverse wave. Basically, the energy that person A is using to move this side of the wave gets transferred over here to person B. And that's how waves can transfer this energy throughout space. Now there's also another type of wave called a longitudinal wave. Longitudinal waves are basically when you have a wave that is transmitted not through upward or downward motion, but by side-to-side motion. So the result looks something like this. You have large sections of the wave that are compressed, and other sections of the waves which are not as compressed. We call these compressions, and these as rarefactions. And basically what this is this represents a sound wave. So sound waves are examples of longitudinal waves, although there are the other types of longitudinal waves as well. So these are the two types of waves. The way to differentiate between them is that this first type of wave here has the particles moving perpendicular to the direction of motion of the wave. The particles are moving up and down, whereas the direction of the wave is right and left. Here, the wave is moving parallel to the direction of the particle's motion. The direction of the wave here is this way, and the particles are also moving the same way. So transverse wave is a perpendicular, whereas longitudinal waves is parallel. Okay,